Hello everyone, this is Miss Chelsea and today we will be learning about mole ratios. Go ahead and try the show what you know questions. Let's go ahead and try number 1. Balance the equation. Sodium chlorate decomposes to make sodium chloride plus oxygen. Notice how on the left side you have 3 oxygens, but on the right you have 2. The best way to make these the same is to make them both equal to 6. So we'll need 2 sodium chlorates and 3 oxygen molecules. Now, once you do this, we now have 2 sodiums and 2 chlorines. So we will need 2 sodium chlorides. Now that everything's balanced, we are done. Based on the balanced equation, we need to identify the ratio of sodium chlorate to sodium chloride. Notice how there are 2 sodium chlorates for every 2 sodium chlorides. This ratio reduces to 1 to 1. Now for number 3, let's consider if 2.8 moles of sodium chlorate were decomposed, how many moles of oxygen would be produced? The question is blank moles of O2 equals 2.8 moles of sodium chlorate. Using our mole ratio, we're going to put our moles of sodium chlorate on the bottom and our moles of oxygen on the top. Why is oxygen on top and sodium chlorate on bottom? Well, that's because we need the sodium chlorates to cancel out. So since we already have one on top, we need one on bottom. We then multiply the numbers on top and divide by what's on bottom to get our answer. 2.8 moles of sodium chlorate will produce 4.2 moles of oxygen. Now let's look at problem 4. If 0.6 moles of sodium chloride were created, how many moles of oxygen would be produced? So once again, we have blank moles of O2 equals 0.6 moles of NaCl. In this case, we want NaCl to go on bottom, so 2, and O2 to go on top. That would be 3 moles. Once we cancel out our moles of sodium chloride, we are left with moles of oxygen. And then we take the 0.6, multiply by the top number 3, and divide by the bottom number 2 to get 0.9. So the answer is 0.9 moles of oxygen. Notice how the mole ratio comes directly from the coefficients of the balanced equation. For problem 5, we're going to figure out how many moles of sodium chlorate are needed to form 4.5 moles of sodium chloride. Once again, we're going to set up our ratio so that the sodium chloride cancels out. So we need 2 sodium chlorides on the bottom and 2 sodium chlorates on the top. If you'd like, you can use the ratio of 1 to 1 instead. Either way, when you multiply by the top numbers and divide by the bottom, you will end up with 4.5 moles of sodium chlorate. Next, let's decide how many moles of sodium chlorate are decomposed when 6.5 moles of oxygen are formed. Once again, we're going to need to put oxygen on bottom because we want it to cancel out with the oxygen on top. So we'll put 3 on bottom, and then on top, we're going to put what we are looking for, our sodium chlorate. So 2 of those. Now, let's cancel out our units. We're going to multiply by numbers on top and divide by numbers on bottom. The answer then rounds to 4.3 moles of sodium chlorate. Finally, we are going to try the challenge question. How many grams of sodium chlorate are formed in question number 6? Let's try continuing where we left off. We know that we have about 4.3 moles of NaClO3. So let's continue our chart, and this time we're going to put moles of NaClO3 on bottom and grams on top. That means that we are going to need to find the molar mass of adding 1 sodium, 1 chlorine, and 3 oxygens will give you a molar mass of 106.44 grams per mole. So we're going to put 106.44 grams on top and 1 mole on bottom. Continue our problem, multiply the top, divide the bottom, and we get an answer of 458 grams of sodium chlorate. You can pause the video and double check your answers to numbers 1 through 5 here. You can pause the video here and double check your answers to numbers 6 and 7.